everyone. Good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 3G. My name is Alesha Mulla, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026 in Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, and the virtual event is being held on Zoom from 9th to 11th April 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes to present and 2 minutes for question and answer. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for today's session. Dr. Saurabh Shandalia is a professor in the Faculty of Computer Engineering at Purnima University in Jaipur, India. With 17 years of dedicated academic experience, he specializes in software engineering, cloud computing, cybersecurity, artificial intelligence, IoT, robotics, smart grids, and other emerging technologies. He is committed to advancing research, innovation, and quality education in the field of computing and intelligent systems. I would now like to request Sir to please say a few words. Is Saurabh Sir present in the meeting?
Yes, I'm here.
Yes, sir. You could please say a few words to commence the session.
We may start. We may start the session.
All right. Okay. So without any further ado, we'll start with the first paper for today. First, we have Konstantina Rigu, who will be presenting AI Explainability Framework and Legal Decision Support Systems. Konstantina, you may now begin your presentation.
Thank you so much. Wait a minute. So do you see my presentation?
Yes, we can.
Okay. Do you see clearly? Okay. My name is Riku Konstantina. I'm research associate and a PhD candidate at Harkopi University of Athens at the Department of Informatics and Telematics. My background is in laws, and my PhD is in legal AI and legal informatics. So I would like to present you our paper that I wrote with my supervisor, Professor Dr. Dimitrakopoulos, and that focuses on the development of an explainable framework and legal decision support systems. So I'm going to start explaining I'm sorry. Okay, I'm going to start with our key motivation, then the objectives and contributions, the core idea and mapping methodology. I will briefly analyze the legal explainability framework, and after I will close with validation outputs. So actually, our goal was to bridge the gap between technical and legal domain. On the one side, AI is increasingly used in high-stakes domains like law, healthcare, and finance. On the other side, we have decisions that need to be explainable and accountable, especially in the legal domain. And now, due to GDPR and AI Act regulations, the requirement for legal compliance becomes imperative. However, the majority of AI systems remain black boxes. So we observe that in European Union landscape, the majority of legal frameworks are referred to concrete obligations for parties, whereas they do not offer any practical implementation. Explainability is a key instrument in AI systems, but we identify a critical disconnect between legal requirements and system design. So, legal compliance actually is not embedded into AI pipelines. There is no structured mapping from law to technical design. There is a lack of explainability criteria and an absence of lifecycle-oriented compliance frameworks. So you might ask, what are we trying to achieve from this work? We had 4 objectives. The first one, to develop a structured approach so as to integrate legal principles into AI systems. Second, to ensure explainability is aligned with regulatory requirements. Third, to provide measurable outputs. And fourth, to enable compliance by design by default. As for the contribution to our paper, we initiate a novel mapping methodology from legal to technical layers. We propose the legal explainability framework called LEAF that is validated through European Court of Human Rights dataset. And finally, we demonstrate the feasibility of the proposed framework without performance degradation. So the core idea behind our paper is to transform legal norms into technical artifacts. More specifically, each legal principle is translated into enforceable technical constraints and corresponding explainability mechanisms that can be evaluated empirically. So we propose the legal explainability framework that bridges legal theory and AI system design by ensuring traceability and accountability. Beginning from the mapping methodology, we identify 4 layers. So the first one is called normative layer that consists of legal and ethical principles. Then we move to technical layer that's composed of system design constraints. We have the operation layer that's made up of explainability mechanisms. And finally, we evaluate through measurable criteria like fidelity, stability, and completeness. So, the structure of the legal explainability framework is circular, emphasizing on continuous compliance, regulatory feedback, and post-deployment accountability. We try to ensure integration of legal requirements at all stages, and what we want it to be applicable across different domains. So it's a life cycle framework for legal compliant AI systems and supports auditability and accountability. So the inputs of legal explainability framework are GDPR and AI Act regulations concerning system context and risk classification. We have the application domain, decision impact, stakeholder roles, and risk level of the AI system. As for technical specifications, include data schema, model architecture, training procedure, deployment environment, and intended decision-making role. So we define in this way the constraints of the system. The process of legal explainability framework, we have ABA models. Actually, AI models are developed and trained subject to the identified constraints. Legal explainability framework embeds governance mechanisms such as decision logging, audit rails, human-in-the-loop workflows, and documentation artifacts. And finally, it requires continuous monitoring of explanation quality, fairness indicators, and legal compliance. The outputs of the framework are decision-level explanations, model cards, audit logs, human oversight, and compliance reports. All of these enable accountability of the proposed framework. To demonstrate the practical applicability of the proposed framework, actually we present a prototype implementation of an AI-driven decision support system in the legal domain. This system is designed to support legal outcome prediction tasks. The dataset comes from European Court of Human Rights. It's a public dataset and includes actually a legal article. All the articles that includes are fully anonymized and GDPR compliant. And it's considered actually a benchmark in legal AI literature. Concerning the modeling approach, we used interpretable models. We try to avoid black box optimization, feature attribution, provides insight into how individual features influence the model's decision. Local explanations are generated for each case in order to justify specific predictions. Model outputs are evaluated based on the legal relevance of the input features, ensuring that legally admissible information is considered. And finally, human validation is incorporated to ensure the correctness of the system's decisions. So the results validate that models achieve stable and acceptable performance. Explainability does not degrade performance significantly. And as you can see, the figure illustrates the frequency of violation and non-violation decisions derived from European Court of Human Rights judgments. The observed imbalance between violation and non-violation decisions reflects the structure of real judicial data and supports the LEAF design choice to prioritize explainability and human oversight. Concluding, actually AI systems can be explainable, legal compliant, and technically feasible, and all can be achieved simultaneously. Concerning limitations that arose, we identified a constrained quantitative evaluation. The validation used from a single dataset. So also in a bigger research, we can use cross-validation or external dataset validation. And on top of that, there is a need for broader testing to evaluate the model on more diverse datasets. As shown from the presentation, we initiated a novel explainability framework that is technically feasible and practically applicable, that maps coherently legal and ethical principles to AI design requirements, operationalizing them through measurable explainability and accountability criteria. So the analysis confirms that feature governance, constrained model development, and human-in-the-loop mechanisms can be instantiated using real-world judicial data without undermining systems usability. So as for future work, we want to extend this foundation with a comprehensive quantitative evaluation pipeline. We will want to test robustness under adversarial conditions, and to make it applicable, to make the framework applicable across different domains, and incorporating standard performance metrics such as accuracy, precision, recall, and F1 score. So thank you for your attention. You can see our emails, and there is the link of our research team at Kharkov University of Athens. And I will be happy to receive your questions, feedback, or comments. Thank you so much.
Thank you. It was good. I doesn't have many queries for you. I just want to ask only one thing about your framework. Have you developed any framework or related to this?
Sorry, I didn't hear you.
Now I'm audible. I'm audible?
Yes.
Okay. I'm just asking you, have you developed any framework?
Thank you for the question. If I understand correctly, we're working on mathematical modeling of the framework. In the context of a journal publication, we want to extend our work, including this one.
Okay. Next presentation, please.
Thank you so much.
Thank you. The next presentation will be by P. Pandyaraja, who will be presenting an intelligent RAG-based chatbot for enhanced and context-aware user interaction. If any of the authors or co-authors are present, you may start your presentation.
Please start.
Afternoon, sir. Afternoon, guys. Myself, Vishnuvardhan Bogi, uh, and my authors are P. Pandyaraja and Shivakumar, Vishnuvardhan, myself, Selvarati, Charles Prabhu, and S. Jagan. And my title is an intelligent RAG-based chatbot for enhanced and context-aware user interaction. And I'm going to present my presentation. And our topic is retrieval augmented generation, which is RAG chatbots that represent a significant advancement in intelligent conversational systems, which is an one step advanced than the other traditional chatbots. And we have pre-trained knowledge of the responses and limited the effectiveness in a dynamic and real world. And we have compared that all real world scenarios to make this chatbot, and we have integrated so many features which are not there in the regular chatbots. And now we are going to integrate the world languages to generate so many types of languages in this model. And we have integrated a system that is all mini LLM version 2 model uh, to give a good response to the user. And we are using a FAISS searching system, which is a Facebook AI similarity search program, which is useful to search the query in the chatbot, and a vector database in the backend. And the main goal of this project is to the document actually a document retrieval chatbot. And we have done so many configured so many features, and we have gained a response latency of 1.3 seconds and a accuracy of 85 to 90 percentage. And our chatbot uh, gives a sorry my chatbot gives sorry, my chatbot integrates NLP language, which is very useful for the chatbots, and integrated AML and machine learning. And these are now widely deployed across the world, which is used in so many sectors like customer services, education, and healthcare. And it is giving so many humanly responses to understand the user. And retrieval augmented generation chatbot provides a more reliable, stable framework for conversational systems because it gives response very humanly. And we have used so many algorithms, and here we have used 3 to 5 algorithms, which is very useful to the chatbot. In that, the main algorithms are NLP and LLMs, FIs, etc. And we have uh, f- we have took so many surveys from the real world, how the user is trying to retrieve the data. We have so many clones for this, like ChatGPT, Gemini AI, Grok, etc. But they are limited source. Without subscription, they won't give so much knowledge. But with this chatbot, we have created a limitless and subscriptionless uh, knowledge by comparing all the chatbots. We have ensured that it should focus on a main goal, that retrieving documents. Like a large number of tokens can be retrieved uh, very easily because the this chatbot goal is only to focus on the main goal. and we have used OpenAI API key to give a response out of the box. And we have in this chatbot we can use so many departments, as I said earlier, education, healthcare, any other legal and compliance departments. And in the context window limitations, we have a limited number of tokens because it is getting paid for that. So we have choose that because so many people are not subscribing these channels, and they are getting suffered. So introducing this will be good for people who are gaining knowledge without subscription less. And we have faced so many issues, and we have crossed them. And we have detection systems, detection algorithms, etc. We have, as I said earlier, we have used a mini LLM version 2 model, and FAISS is very much useful to our project to search the knowledge box. And query process and intent analysis is good because we are using NLP and intent recognition, contextual interpretation, etc. And retrieval components are usually files index vector repositories, and using all the mini LLM version 2s. And the embedding also very relevant to the documents. And the response generation module is very high in integration because the user and supplied to the large language module, which generate a very humanly and accurate response to the grounded in verified information. The knowledge base is constructed from well structured PDFs or Word files or any type of files, and it will be stored in this knowledge base after created into small chunks. And prior to indexing, all data undergo pre-processing. Like it will check the all data, raw data, remove spaces and any noise from the raw text. It will keep the data very clean, consistent, and very high quality. And this is the architecture of RAG. The user is giving a query with a document. It will store in the vector database, and the small vectors will be go to next stage to get retrieve the raw text data, and then it gives generation. And using LLMs and many more algorithms, it gives a natural response. And these documents are partitioned using a single window, which is 512 tokens. Each token contains 3 to 4 English character words, and each all these 512 tokens will be divided into each one chunk. One chunk contains almost 500 tokens. And using the algorithms, we are able to differentiate all these things. And using files is very much important because it is open source, so we can search according to the query, and the latency also low compared to pinecone similarity search. User queries are encoded with some protocols. During indexing, the files nearest neighborhood search retrieves, like I said earlier, as tokens, and the retrieved chunks are subsequently ranked according to the protocol, and it will keep in the order how
Excuse
the.
me, I'm sorry to interrupt. You have about 30 seconds left.
Yeah, okay. Go to that question. This is our main main implementation code of Python. This is the system configuration to use this chatbot. It should need a definite GPU. With only CPU, we cannot run this because the system overheats. And to run these large models, we need at least NVIDIA 3050 GPU. So the latency would decrease by using the higher configurations. And this is the preview of the chatbot. And our conclusion is it is tested with various documents and various number of data, and we have checked with all the sites. The rogue L is have we have a rogue L score of 0.67, and we have a score of yes we have score of rogue 0.67, which is a metric we have achieved in this testing. And these are the authors, references we have referred from these papers. Thank you.
Okay, I want to ask you one question.
Yes, sir.
I'm audible?
Yes, sir.
Hello?
Hello.
I'm audible?
Yes, sir, you are audible.
I'm audible?
Uh, yes, sir,
Yes,
you're
sir, you are
audible.
audible, sir. Yes, sir, you are audible, sir.
What is
Post the question, sir.
yes? What is context awareness?
So context awareness is where the user is giving the content, and the chatbot is giving the response according to that. And the context awareness means it will give the previous history of the user and the relevant documents,
And
which is
just a minute, just a minute, just a minute. I add one more query here. Uh, how it is helpful to enhance performance and response quality?
sir, user is using our chatbot means we don't keep any restrictions. Our chatbot only focuses on document retrieval itself. So other works which gives loads on this chatbot will never give load on this chatbot, sir. So only focusing on document retrieval makes easy because using so many large modules.
Okay, you may leave.
Thank you, sir.
Thank you, sir.
Thank you. You are requested to not leave, but we will move on to the next presentation. The next presentation is by Manjula K, who will be presenting analysis of decomposition levels and vanishing moments in wavelet-based processing of ultrasonic TOFD A-scan signals from authentic stainless steel weld pad. Manjula, you may now begin. You're actually muted.
Am ma'am, am I audible?
Yes, you are.
Yeah, thank you. Good afternoon, one and all present here. I'm J. Manjula. Here, our title is Analysis of Decomposition Levels and Vanishing Moments. In one second, ma'am. Vanishing moments in wavelet-based processing of ultrasonic DODACM signals from austenitic stainless steel weld pad. These are the things that we are going to discuss in this. Generally, welding is the process of joining two metals or materials together permanently. Here, many things around us are welded, and it is used in many industrial applications. During this process of welding, or even at a later point, the defects may occur. In general, defect is any interruption in material homogeneity. Here, the defect may or may not be within an acceptable limit. If it is beyond the acceptable limit, it makes the component unfit for service. So it should be detected, and we should ensure the quality of the product. And here, these are all some of the papers we reviewed, many papers we reviewed out of those. These are some of the papers using that we obtained the research gap. Here, most of the authors have not considered on the selection of decomposition levels and the vanishing moments in wavelets for denoising actinitic stainless steel weldments. So, welding plays an important role in all fabrication industries. Defects need to be identified in its earlier stage to ensure safety and quality. To do that, instead of using destructive methodologies, here non-destructive testing technique and especially ultrasonic DOFD testing technique is used. Here, our main objective is to analyze and interpret the signals of welded defects which were collected from ASS weldments. Here, to do that, to analyze and interpret the signals, first thing, signals have to be enhanced using DWT, that is discrete wavelet transform, by analyzing decomposition levels, the vanishing moments of simulate mother wavelet. Here, the first thing, the methodology which we use to carry out this, first the signal acquisition. The signal acquisition is done with the help of time of flight diffraction technique. This is one of the ultrasonic testing techniques. Using that, the signals already that is here in our work, we were acquired n number of signals from the different positions of the weldment. And this is a complete setup for acquiring signals from the various specimens. And here, and whenever we acquire signals from the specimen, those signals are in the form of that is those signals are to be processed using XVO software, and this WVF file gets converted, signal files get ASM signal gets converted into XLS files. And this right side, this is here the acquired signal. In general, whenever we acquire signals, here especially, here this left side figure shows radiographic image of actinitic stainless steel weld pad with notches. Here we were introduced notches while fabricating this specimen, and the dimension of the specimen is also specified here. And from third notch, here, the acquired signal is given at the right side. And in general, whenever we acquire signals from the specimen, it may or may not affect. In general, most probably it gets affected by means of noise, such as instrumental noise or material noise. Instrumental noise may be suppressed even by means of the instrument itself. But material noise, it may be caused by means of grain structure, that is the structure of the material. So these noise must be suppressed to get the proper information, the proper defect signal or the status of the signal. To do that, signal must be enhanced. Here we were used DWT for achieving that task. And one more thing, here a discrete wavelet transform, that is multi-level DWT decomposition using simulate wavelet filter with a suitable vanishing moment is considered here. This figure shows multi-level DWT decomposition. Whenever input signal is given to this algorithm, this transform, it gets segregated into two coefficients. One is approximation coefficients, another one is the detail coefficients. Approximation coefficients has the information, meaningful information, and D, that is detail coefficients, generally high frequency components. This is nothing but noise, may be considered as noise. So how many times we do that? So based on that, here multi-level decomposition can be done using this. And this here the first figure shows one of the acquired signal from the third notch, and this signal gets decomposed using 4-level DWT with similar same 2. Here 2 represents vanishing moments of that wavelet filter. That is, here the wavelet filter is of type simulate. the right side shows the denied signal of that. And instead of considering SIM to wavelet filter, vanishing moments also increase. This table shows simulate 4, vanishing moments 4, 5. Similarly, we used n number of vanishing moments, different vanishing moments we were used, and we carry out the process. And we found SNR improvements for those signals. And after getting those information, here this table shows SIM5 for 4-level DWT decomposition gives a higher SNR improvement. Here it is 102.67 decibel. And one more thing here, instead of using 4-level DWT decomposition, here we were used multi-level DWT decompositions. For the same signal, here we used 4-level DWT decomposition, 8-level and 30-level. Out of these values, here SIM5, when we denize the signal using SIM5 mother wavelet, and at high level, that is 30-level decomposition, it gives a higher SNR improvement value than that of 4-level and even 8-level. And this is the observation that we obtain using this. The pictorial representation of the same thing is given here. Again, it shows the SIM5, the blue color indicates using SIM5 mother wavelet signal gets that is enhanced. And here level 4, 1 or 2, it represents using 4-level DWT decomposition and 8-level and 38th level DWT decomposition. So the different multi-level DWT decompositions were used for denoising using like a SIM5, SIM35 and a SIM36 mother wavelets. Here, meantime, we also calculated the computational time when we go with these multi-level DWT decomposition with various that is simulated with the different vanishing moments. Here the first figure shows the denoised signal using SIM5 with the decomposition level 30. For this, here the computational time which takes is 0.143 seconds. That is, the second figure shows the same signal gets denied using SIM36 with the decomposition level 4, whereas that computation time is approximately 1.3 seconds. Here a time here and using that specimen, the number of signals acquired at different positions of those 3 notches. Here some of the signals and its SNR improvement value and the time computational, that is time is also specified here displayed here. From this SIM5 with level 30, that is multi-level, higher level DWT decomposition with a lower order simulator gives higher SNR improvement, and also time computational time is also less when compared with SIM36 with the levels 4. So from this, what we observed, better performance is achieved with lower order wavelets at high level DWT decomposition. Example here, SIM5 at level 30, it works well and it outperforms SIM36 at level 4, and computational time is also less.
Excuse me,
And
ma'am, you have about
yes,
a minute left.
yeah, yes, ma'am. So from this work, here the final conclusion is here signal. Here very first we acquire the signal and we want to enhance the signals. Here to do that, here a DWT with a similar wavelet filter used, and SNR improvement achieved using high level DWT decomposition with lower order mother wavelets. And so this is the final finding from our study. And these are all some of the feature work which is to be included at later point. And here we used only SNR. In addition to that, we will, yes, sir.
Okay, I got your point.
Yes, sir.
I want to ask you one question.
Yes, sir.
What are vanishing movement in wavelengths?
Here, vanishing moments here, which is used to smoothen the signal. Here we used vanishing moments, vanishing the unwanted informations or else regularity of the signal can be obtained when we go with vanishing moments. So every wavelet filter.
I think these are helpful for finding defects.
Sir?
These are helpful for finding defects.
Yeah,
Vanishing movement.
Yes, sir.
Vanishing movement, I
Yes,
think helpful for finding defects, but you are not discussing about that.
Yes, sir. Like which one of the, instead of considering general vanishing moments, wavelet filter with vanishing moment X, here like what it would be, and similarly what will be what a decomposition level instead of considering 4 level or 5th level decomposition, what it will be. So for that we are trying this also. We tried this.
I'm not satisfied with your answer. And one more question is, what is Fourier transform?
Sir, Fourier transform.
Yes.
Fourier transform here that is the frequency components. Here using wavelet we obtain time and also space. Yes, sir.
My next question will start
Frequency.
from your answer. My next question will start from your answer. Why wavelet instead of Fourier transform?
Sir, faster calculation and also like defect can be identified. That is the location, and so these things can be done easily. So when we surveyed, we found that that's why we go with.
Okay, we can go for next presentation. Thank you.
Thank you, sir.
Ma'am, please bound everyone to take not more than decided time, okay?
Yes, sir, of course. All right, so we'll begin with the next presentation now. Next, we have Vinay Kumar Pamula, who will be presenting error rate analysis over Air-Beaulieu and Air-Beaulieu extreme fading channels in additive wide generalized Gaussian noise. Vinay, you may now begin.
Yes, madam. Is my screen visible?
Yes, it is.
Okay. Thank you, madam. Good afternoon. I am Dr. Vinay Kumar Pamula, and my presentation is on error rate analysis over alpha Beaulieu and alpha Beaulieu extreme fading channels in additive white generalized Gaussian noise. So this work is based on the BTech final year project work. So here the first 3 others are my students, Likita, Raghavramya, Anuradha, Appal Swami are my students. And we are from JNTU, Kakinada, India. The modern channels like high-speed railway networks and femtocells, small cells, have multiple LOS. Classical models like Rayleigh, Nakagami, they may not capture these reflections or specular components accurately. So that's why Beaulieu proposed a new fading model, and that is named as Beaulieu fading channel model. So here later alpha component is also included, and alpha BX and its extreme versions were introduced. So here the alpha is a nonlinear parameter, and that is more flexible modeling compared to the Beaulieu fading model. And another thing is the extreme fading model is suitable for when the signal outage is more, especially in the urban environments. And the noise model that we consider is additive white generalized Gaussian noise. The reason behind considering this noise model is, so here we have the noise parameter that can be varied so that it includes Laplacian noise as well as impulsive noise, and we can have the uniform noise also. So this is the received signal model that we consider. This is the general received signal model. R is the received signal. H is the fading channel coefficients. S is the transmitted signal. N is the additive noise. Here in our work, this is important. The noise model that we consider is additive white generalized Gaussian noise, and its conditional BER uh, can be expressed as this equation in terms of Fox H function. This H2012 is the Fox H function. And here we can see the parameter A is the noise parameter, and by varying A, we can have different noise models. For example, when A is 0, we have impulsive noise. A is 0.5 gamma noise. A is 1 Laplacian noise. And A equivalent to 2 gives the Gaussian noise. And when A tends to infinity, it's a uniform random variable or noise. So here, the fading channel models that we consider are alpha BX. This is the standard model, and its extreme version, alpha BXE, is also considered. And the probability density function of this alpha fading channel is given by this equation. Here, the N is the summation value that is that can be infinity also, but in this work we considered N is 20 because that is suitable. That's why we choose an N equivalent to 20, and these are the other parameters defining for this particular probability density function of alpha Bx. And another channel model that we considered is alpha Bxc extreme fading channel model. So here we have an extra Dirac delta function term that indicates the deep fading scenario. So that's why this is the more generic fading model. So that's why we have chosen this alpha BXC, so that the performance of the communication system can be analyzed in extreme fading conditions. So in our work, we derived exact closed form expressions for the average BER. So this is the general expression for the average BER, where A, B are the modulation dependent parameters, and this F gamma of gamma is the fading channel probability distribution, probability density function, and this is the noise density function. So here we used the Fox's function and the product of the Fox's functions, that is integral involving product of Fox's functions. So here by substituting this F gamma of gamma and the noise PDF QA of X. So here we evaluated this integral and we obtained this closed form exact expression. And as far as our knowledge is concerned, this is the first expression that we derived. And another expression that we derived is for the extreme fading condition. So in this case, we considered this density function for extreme fading, and we substituted that here, and we got this expression. Okay. So here, because of this extra term due to the delta function, this we have an error floor in the probability of error. Okay. So these are the simulation results as well as the numerical integration results that we obtained. This is for the first expression that we derived, this one. In our paper, this is the equation 9. So we used MATLAB programming to evaluate this particular probability of error. And in order to validate the analytical results, we presented the simulate, that is numerical integration results also. Here, the solid lines as well as the dotted lines indicate the analytical results, and these markers, white markers indicate the numerical integration result. So both are matching perfectly. So that indicates the derived expressions are correct. So here, from this probability of error curves, it is observed that the analytical results are perfectly matching with the numerical integration results. And the Laplacian noise, that is for A equivalent to 1, for A equivalent to 1, it is a non-Gaussian impulsive type Laplacian noise. So it causes higher error than the Gaussian noise case when A equivalent to 2. So here we considered this case for A equivalent to 2 BPSK, A equivalent to 1 BPSK, and A equivalent to 1 BFSK cases. And here we observed that when the noise is considered as Laplacian, then the error is more, the bit error is more, and when it is reduced, it is reduced when SNR is increased. And another thing is the alpha also plays an important. So here, when alpha is increased, then the probability of error is more. When the alpha is reduced, so we can observe the probability of error is reduced. And another thing is the channel coefficient fading parameter. So here M equivalent to 0.5 indicates the extreme fading scenario. So under extreme fading conditions, the probability of error is more. And when the fading severity is reduced with M equivalent to 2, then the probability of error is reducing with increase in SNR. This is the result that we obtained for the second expression that we derived. This is a probability of error expression that we derived for extreme fading scenario.
So we have limited time for every paper.
Yes, sir. Yes. So it's over, sir. This is the last slide. So here we observe in the under extreme fading conditions, even though the SNR is increased, almost the error floor is not changing. And once even at higher SNRs, the error flow remains same. That's what we observed with extreme fading conditions. So we derived exact ABR expressions for different modulation schemes over alpha BX and alpha BXC channels in additive white generalized Gaussian noise. And here it accurately models non-Gaussian as well as impulsive environments. So Laplacian noise significantly degrades performance compared to Gaussian. And alpha BXC model reveals critical irreducible error flows and high blockage scenarios. That is, a signal is lost almost completely. And we would like to extend this work for MIMO systems and outage analysis for MRA quadrature amplitude modulation schemes for both alpha BX and alpha BXC channels. So these are the important mathematical identities that we used in our work. And these are the important references that we used. I included only 5 references here. So thank you very much for your patient listening. And now I'm open to questions. And I'm also thankful to the ICTIS organizing team for this particular wonderful opportunity.
It's good. I want to ask you some question.
Sir, please,
what happens if noise increase significantly?
Sir. Sir, your voice is not audible, sir.
I'm asking what happens.
Sir.
Now it is audible?
Yes, sir. Yes, sir.
what happens if noise increases significantly?
Yes, sir. If noise is increased significantly, the degradation system degrades. The performance of the system is degrading, sir. So that's we observed in the
Speak
simulation.
loudly.
Sir, when the noise is increased, the performance of the system will drastically reduce it, sir. So that's what we observed in the simulation results also, sir. So here, when in A equivalent to 1, so noise severity is more, sir. And we observe the probability of error is also increasing. That is, the performance of the system is degraded.
What is AWGN?
AWGN is the additive white Gaussian noise, sir.
Thank you.
Yes, sir. Thank you, sir. Thank you very much.
All right. So our next presentation for today is by Deepak Mane, who will be presenting Machine Learning-Based Automated Subjective Answers Evaluation System. You may now begin your presentation.
Ma'am. It is visible?
Yes, it is.
No. 1 minute.
I think you are opening Google Chrome. You should do
Yeah,
something.
sir.
You should
one
share your
minute.
screen.
Yes, sir, now it's visible?
It is. Yes, it is.
Yeah. Okay.
Will you start from first slide
Yes, sir.
where I can view your title also?
Sir, this is my first page.
Okay, this is your title: Information Communication Technology and Intelligent System,
That
Thailand.
was the conference name, and our project title is Automated Subjective Answer Evaluation System.
Okay, got it.
Okay, so coming to the introduction, as we all know that manual handwritten answer evaluation is a very time-consuming and inconsistent method, and it leads to the heavy workloads for evaluators. Sometimes evaluation may be done by personal bias, and it leads to the loss of student performance. So, to avoid this and to overcome these challenges, we have designed a system which automatically evaluates subjective answers using machine learning and NLP. It not just does keyword matching, but it understands the meaning and the context of that answers and then match it with the teacher's answers. Also, our system provides fast, fair, and consistent grading. Next, in literature review, basically we studied various advancements in automated.
May I stop you, please? Can I ask you, is it your review paper or something implemented paper?
We have did research paper, and literature review is this literature review is from our research
No.
paper.
I'm just asking, is this your paper? Is review paper, or have you did something else other than review? Do you understand what is the review paper?
Sir, can I show you our paper?
No. I'm asking, do you
No, sir,
understand
this
what
is not
is
a
review paper?
No, this is not a review paper. This is a.
So, if it is not review paper, then I don't think that your title is suitable.
Which title? Literature review?
No. Your presentation title.
Automated subjective answer evaluation system. This.
Yes, this is not. This could not be a title. This could be
Sir,
a project. This could be a project of engineering student. I don't think this is a proper suitability for title.
Sir, this is our project, and our research paper is based on this project. So that's why
So what is the title of your research paper?
saying automated subject to answer evaluation system.
I'm not satisfied. I'm not satisfied with your title. But still,
Can you check it once again? I can show you my paper also.
so move to on research methodology. What you done here?
Here we have studied this point. Can I
Do
explain
not
it?
discuss this literature review.
Okay. So this is the methodology.
Move to methodology.
Yes. Okay. So, sir, here first phase is the input phase. In this phase, basically our system is taking handwritten answer sheet from the student, from the teachers, and also related subject-wise question papers. Here user can upload those things. Now the second stage is the pre-processing stage. Here handwritten answer sheet image is properly cleaned up. That is a text made more clearer.
This
Handwritten
is not methodology. This is not methodology. This is workflow.
Yes, Miss kind
So
of
what
same.
you done in your research paper? What
Sir,
what
I
is your
will
key finding in this paper? Will you move for next slide?
These are the experimental results of our system.
Next slide, please.
Our UI image.
Next, please.
Comparing with existing model.
So what is your model name is?
Modeling automated subject to answer evaluation.
Next
Means
slide, please. What do you find here?
I can't
move to last slide. Conclusion.
So basically, sir, our
I'm
system
reading your
is
conclusion. Okay.
yes.
So what's new in this? This is this all is in market.
Sir, here we have mostly the available sources. They only depends on mostly on the keywords matching. But we
Yes,
have
sir.
combined here the semantic matching. So they don't use transformer-based models for the semantic matching. So we have integrated that and various other fields are checked while evaluation.
Okay. Where you mention semantic similarities.
Sir, I
In your
mentioned in
PPT.
workflow. Here you can see
Where
that
is semantic similarity?
semantic comparison. Also, I mentioned in the literature means whatever we studied from literature.
That's why I asked you where is mentioned in your project in your methodology.
Yes.
Okay. Okay. I think you should work hard on this and more efforts required. Okay.
Okay, sir.
Thank you.
All right. So we'll move on to the next presentation. Next, we have Deepak Mane, who will be presenting multi-leaf crop disease detection using EfficientNet B0 with transfer learning. You may now begin your presentation.
Yeah. Is my screen visible, sir? Hello.
Yes, your
Ma'am,
screen is visible, but you're barely audible. Please speak up.
I'm audible?
Yes, you are.
Okay, fine. 1 minute. Yeah, so good afternoon, sir. So basically, my presentation is on multi-leaf crop disease detection using efficient net with transfer learning. Yeah, so basically, this will be the um, is an important cooking plant, but due to this eating and wilting that reduces quality in production. So basically checking these leaves manually, it's a lot of time and for the farmers also, and can give wrong results sometime. So we decided to use a deep learning model to automatically detect disease from image of multiple leaves. The image can contain multiple leaves in a one particular image, and farmer can easily detect what particular plant, which helps farmers detect disease early. It can take quick action and protect the crops. So basically, this AI-based system will support smart farming and reduces losses. Yeah, so every year in India, like losses of crops because plant diseases are detected late, and farmers usually check plants manually, and which is slow and sometimes incorrect. So in rural areas, experts are not always available, and with deep learning and computer vision, we can detect diseases automatically using images, which may help farmers to get fast and reliable results as soon as possible. So pronunciation basically focuses on basil leaf disease like mildew, mildew and wilt. And manual check is also slow and needs expert knowledge. So basically, to solve this, we developed a deep learning model that will classify leaves into three categories: healthy, wilted, and wild leaf, and which will help in early detection and reduce pesticide use and support smart agriculture. Yeah, so basically we have several research papers, and we have put a comparison based on this, like what data sets that this particular paper have used and what technology they have applied, what are its risks and limitations. So some of them have King's clustering, and then efficient net, B3, etc. And as per their results and
Arya, will you come on your methodology, please?
yeah,
Yeah, will you come on your methodology section in your PPT?
yeah, my PPT is visible now, sir.
Yes, yes, yes. Move next.
Yeah, yeah. So
I just want to see how you will train your model. I'm audible?
yeah, sir, you are audible. So like
I
this
just
is
want
the
to
what
know. I just want to know how you will train your model.
basically
I just want to know how you will train your model. Next, please.
various process
Have you listened my question?
optimization.
Arya,
Actually,
have you listened my
yeah.
question?
Actually, my internet is unstable, so
Move back, move back,
hello.
move back. Previous slide.
Sir, we have resized
You
images,
just
normalized,
write
and apply
here.
random.
Have you implement something? Yes. I just want to ask this.
Yeah, sir, can I go to the results and show
next.
like what the output is there? So we have got
Yes,
this
you may.
confusion matrix and accuracy versus loss graph. And next, like we have built a Streamlit tab
But still, okay.
where the user can upload your multi-leaf images, and accordingly it will detect like the it is mildew, this particular image is healthy, this particular image is wilted. And yeah, so this is our results, and we have achieved accuracy of training and testing accuracy of 96.6 and 97 percentage.
Okay.
These are
how
the
you
references that
just a minute. How you get your data set? On previous slide, I want to know your conclusion. Conclusion only.
Sir, is it visible?
Yes, it is visible. I just want to know why you use efficient net BO model only.
First of all, we have tried various combinations of model like using CNN, using efficient net.
Can you explain what is efficient net BO model?
Sorry, sir, you are not visible. Can you
No,
repeat?
I'm audible.
Yeah, sir. Yeah, please.
What is efficient net BO model?
Efficient net B0, sir, we have used.
Yes. What is this? You don't know?
Hello? Hello?
You don't know?
The internet is little unstable here.
Okay, thank you.
Yeah.
All right, so we'll move on to the next presentation. Next, we have Sajal Kishore Papteja, who will be presenting night patrolling system using CCTV and real-time violence detection with IoT and AI. Sajal, you may now begin your presentation. Are Sajal or any of his teammates present in the session?
Ma'am, how more presentation are pending?
Just 1 second. We have 4 presentations pending.
4.
Now, if we're skipping Sajal, we have 3 pending.
Okay. So he is available now?
I don't believe he's in the meeting. We'll move on to the next presentation.
Okay.
Next, we have Deepak Mane, who will be presenting real-time multimodal vehicle type classification system using deep learning. You may now begin. Are any of Deepak Mane's co-authors present in the meeting?
He is not here?
Okay, I don't see in the meeting, so we'll move on to the next presentation. Yeah. Next, we have Shweta Ramdas, who will be presenting reducing methane emissions in rice cultivation using federated learning, a privacy-preserving framework for climate-smart agriculture. Shweta, you may now begin.
Shraddha is not available?
Shweta, I see you in the meeting.
Yes, I'm available. Just give me a minute. I'll just try to share my screen.
Shweta, are you there?
Yes, sir. I'm just trying to share my screen. I'm not able to share the PPT. Just a minute.
Okay, no issue. I'll ask something from you, from your title. I have your title. Your title, can you explain your title, please?
Sure, sir. Just give me a minute. I'll share my screen. It's ready. Yes. Yeah, so my project title is Reducing Methane Emission in Rice Cultivation Using Federated Learning. So, so the title meaning is that here I'm using IoT sensor data of the farm fields of the rice production, and using that data, I'm trying to predict the methane emission using machine learning models. So here I've used some of the machine learning models, which I will talk about. And along with that machine learning model, I have embedded the federated learning framework. So what exactly federated learning framework is that it tries to preserve the data which is embedded of the data of the farm fields which we have used.
Okay. Same question which I
Mm-hmm.
asked to previous presenters. That was about their methodology. So same question, you use IoT. So are you developing any hardware?
No, sir. My research is based on AI and machine learning using the
Okay,
federated
that's
learning
that's
framework.
that's good. That's good.
Yes.
So I ask how you will train machine.
Mhm. Yes. So, coming to the point, as I said that I'm using the sensor data set. Before that, I'll give you a short overview, like how I'm using it. Is that I was working on a research of the USDA government, that is the United States Agriculture Government in USA. So they were funding our
You
project.
belong from USA?
Yes, sir. So I'm doing my master's. I just completed. So I'm presenting my research paper. Hello, can I continue?
Yes.
Yes. So this was one of my project during my master's. I have graduated now, so I'm just presenting that paper right now. So I worked on the research with my supervisors, Dr. Kritika and Dr. Sudhir Trivedi. So and there were other people too. So my part was to predict with the AI and machine learning models. So I used the sensor data which was provided by the farmers, which we collected, affiliated with the Supreme Rice Company. So we worked with them. So using that data, I did data pre-processing, and then I did feature engineering, and I selected soil, moisture, and pH level of the sensor data, and then I used four models: XGBoost, linear regression, and random forest, and I use the feed forward neural network. So using these models, I collaborated and tried to predict the accuracy. And using the feed forward neural network, we can try to make the data centralized. Usually with these models, the linear regression, random forest, and XGBoost, we can try to find the accuracy of the data. And then if we need to make it centralized means accessible at one place. So these models I used first and trained the accuracy to try to predict the methane emission. And using these three models, after that I embedded with the feed forward neural network. What this one does is it tries to centralize the data server, and using this model we can try to do in the further future work is that we can connect it with a real centralized server, and it can be implemented where the data which is given by the farmers and which is collected from their sensor IoT sensor data, which we can preserve it using this feed forward neural network. So that will be implemented in the future scope. And let me walk you through the architecture of my project. So architecture is, as I said, we use the sensor data, and edge device is nothing but we used data cleaning and processing the data which we got, and then we try to locally train using these machine learning models, and after that we try to use the simulated federated neural network server so that we can try to connect with all these client models and try to keep the data preserved, which is what we're trying to achieve it in the future scope. So the federated neural network has accuracy of 0.99 compared to the other models, and it's quite accurate, and even the XGBoost model is also giving quite better accuracy. So this is what we are trying to achieve, is that we want to have scalable data, and we want to preserve the data as well across the farms, as we are using multiple farm data. So we want to preserve that data, and using federated learning, we can achieve that. And the impact of non-IID data, what it means is we are trying to analyze the client data across different servers and using the model. So we are trying to find the accuracy in the using the federated learning framework. So
Okay. That is quite okay. That is quite okay. I got everything from. Come on, conclusion.
Okay. So conclusion is the same thing which I just mentioned, that using this data we are trying to streamline into a federated learning framework so that we can achieve the data privacy. And in future we would like to implement blockchain, as we already have a website which we connect the data of the farmers. So later on we like to implement it with this AI machine learning model to preserve our data.
Got it. Got your point. Your paper is good and your presentation is too good. Thank you.
Okay, thank you, sir. Can I stop sharing the screen?
Yes, we can go for next presentation.
All right.
Thank you, sir.
Our next presentation for today will be by P. Pandya Raja.
I think this one is last presentation, no?
Yes, it is. All right. So P. Pandya Raja will be presenting Secure Knowledge-Based Financial Assistant using RAG. You may now begin.
Good afternoon, ma'am. I'm audible, ma'am?
Yes, you are.
So, good afternoon, ma'am. Yeah, our project title is Secure Knowledge-Based Financial Assistant using RAG. And these are our authors, Mr. Pandya Raja and Krishna Kishore, Ganesh, Selvarati ma'am, and Charles Prabhu, S. Jagan. Just one second. Petrol. Yes, petrol. That's better. Snacks over, no? Snacks, no. Guess, yes. Our abstract is retrieval augmented generation based financial chatbots, and it represents a significant advancement in intelligent financial assistance, and it mainly focus on accuracy, reliability, and secure knowledge-based delivery. The traditional financial chatbots rely on static rules or pre-trained knowledge, which limits their ability to handle dynamical financial queries and real-time information. It constrains the proposed financial like chatbot, and it incorporates real-time financial knowledge based the system to adapt challenges and market trends.
I'm interrupting you. What type of financial assistance you want
Yes,
that is not mentioned in your abstract?
yes, so spending expenditures and our financial data, sir.
Where it is mentioned?
Actually, yes, sir. In the last line,
It is written in your title.
yes, sir. In introduction, it's written.
No. I'm asking. Is it written in your title?
Yes, sir. Secure knowledge-based financial assistance. It is used for
Yes.
mainly for financial assistance.
So what is secure knowledge based system?
Sir, it's for analyzing the securing our financial data, sir.
No, I'm just asking. What is secure knowledge system?
It's a user-friendly chatbot system, sir.
Chatbot system.
Yes, sir.
Okay. Come on. Just. How you find a data set? What you did for finding of data set?
Sir,
Do you use any data set for this paper?
yes, sir. By Hugging Face A and camels.
Where is it? Show me that data set.
One second.
Where is your data set?
1 second, sir.
You can share it there. You can share it there. Data sets. You can share the link.
Yes, 1
You can
second.
share the link. Oh, shit. So I will be asking,
Next, please. I'm just asking. What is no issue? Come on, conclusion.
Yeah, also 1 second. I would like to conclude that our project is the systems which as our chatbot achieves a retrieval accuracy of 87.4% and a response latency of
Just a thing. How you find 87.4?
accuracy.
What you use of getting this 87.4?
By giving by
What is the data? Where is that data?
the metric used to evaluate automated text summarization.
No. I just want how you find. I'm talking about that data. Where is that data?
Sir, the data set is available from this Google, sir.
Where is that? Have you
Sir,
mentioned in
share
your
the
PPT?
Yes, sir. No, sir. I'm not mentioning here. Okay, I share the
No
link
issue.
also.
Thank you.
I'm share the link also. Okay.
Thank you.
Based
Thank
upon
you.
based
may
upon analysis,
conclude. We may conclude, but for further, you must discuss about data. Okay.
Okay, fine, sir.
Thank you.
Yes, sir. The data is already there, sir. We are getting this.
No issue, my dear. No issue, my dear. Thank you.
Okay.
So, ma'am, can we conclude?
We may. Just to quickly, we had a few presenters who hadn't had a chance previously. We'll just see if they're available. Yes, sir.
My paper ID is 1632.
Okay, just 1 second. Was this your paper?
Yeah, real-time multimodal vehicle type classification. 1632.
All right, 1 second. All right, there we go. Okay, so yeah, you may now begin your presentation.
Yeah, shall I share my screen?
Yes, you may.
Is it visible, ma'am?
Yes, sir.
Okay, so good afternoon from India. And now on behalf of my students, I am here to present my paper, which title is Real-Time Multimodal Vehicle Type Classification Using Deep Learning. So in this paper, we propose one vision transformer, which is able to classify the vehicles in different categories. For that, we are use the one standard data set, and we applied some deep learning based algorithms on that, and we tried to improve the accuracy. So our main objective behind this is we are improving the accuracy, not modifying the algorithm. So here now whatever the study is present for this title, it is all about vehicle type classification on image or vehicle type classification based on the audio. So here we are trying to use one data set which is a combination of both visual as well as audio. And there we are using some deep learning models, and using that we are trying to improve the accuracy on that standard data set which is available on the internet. So whatever the study is present for this title, it is all about saying yes, deep learning, there are different models of deep learning, different architecture like as yellow, efficient net, resonate, google net, or customized CNN we can use for classifying the vehicle type classification in different category. But here no one is saying if due to the different limitations, or we can say the challenges, if we unable to classify the image, like as if noisy image is there and in front of camera due to the some error, or due to the some any kind of error, if we cannot recognize the particular vehicle, then how we can say which type of vehicle is there. So our intention behind that, if we add the audio with that image, then definitely we can recognize that image properly. Like as if I am taking a simple example, like as one vehicle is going in speed on the road, and we can't recognize the exact vehicle, but with that vehicle, if audio is there, like as a silence of hospital or ambulance silence, so based on that audio also, audio can help us to recognize that vehicle in different category, like as this is the ambulance, maybe ambulance because of this emergency, it is going fast through on the road. So this is the main intention behind uh, our title. So for that, our objective is we are using the both data, audio with the audio with the video, and we are trying to recognize this data on real time. So this is the objective behind that. For that, we are initially saw the different models. Many models are available on the internet. So initially we tried with the CNN, then we tried with the yellow, then also we are trying to combination of the different deep learning models. Our main aim behind that, we need to improve the accuracy, and we need to handle the both data, audio and video. So for that we required the data in combination of both, and we have done the small type of pre-processing, and with combination of the yellow and CNN we extracted the features from that image, and then we need to classify, and that classification we did the small type of pre-processing, like as a resize the image, normalize the image, or augment the image. So this kind of pre-processing we applied on that images, and this is our proposed model, where you can see as an input we are taking the both camera based input and audio based inputs, and after the pre-processing whatever the models we have, that model is able to understand that features from that audio and features from that video, and based on that both combination fusion. So we are saying that this is a transformer based vision transformer. Nowadays we can say this is another approach we can use for this such kind of applications, where we can combine these features, and finally we can produce the results, like which type of vehicle is there. And the classification of vehicles is also important factor when we are talking about the traffic intelligence system as a part of the smart city, when we are applying such kind of application. So such kind of things really will help us to do the some task related different tasks in the part of the traffic intelligence system.
Any use case available?
Sorry, sir.
Any use case available?
Use case of label means, sir, already the data has a label, and really we are not applying on the real time, but we try to apply our system on real time, whatever the video are available on that data set. In that
that means it is conceptual model.
Yes, sir.
So there is no result.
Yes, sir. Yes,
there is
yes,
no
sir.
result. There is nothing.
Yes, sir. Please.
There is no result. There is no data.
Yes, sir. Data set is available on the Kaggle.
So how you will improve accuracy? You are talking about accuracy, and your entire research is for accuracy only.
Yes, sir.
Am I right?
Yes, sir. Yes, sir.
So how this accuracy will increase?
Okay.
Do you have a previous accuracy model?
Yes, sir. We compare our result with the existing approaches. So we saw some papers.
So how you will reach on results with your model, which is conceptually?
Okay. So sir, we hyper tune the existing model, not modifying. So as per the requirement, we add some extra layers. We tried on the different batch size. We tried on the run the different activation functions. We tried on the different concept to handle the overfitting. So we can say the hyper tuning base. We did some customization, and we got accuracy. So this data set is available on the Kaggle, sir, and it is almost 5,000 images in that. Classes are car, bus, truck, motorcycles are there. And when we implemented, and when we see the output, this is some outputs on the screen. You can see it classifying the different vehicles, like as a motorcycle, cars.
Okay, no issue from my end. No, okay.
Okay, these are the results, sirs, and when we compare our results with the existing, this is our highest accuracy, which is 96.2. As a conclusion, yes, as per our need, as a conclusion, as per our requirement, we hyper-tune our existing models, and we improve the accuracy for the vehicle type classification for multi-model data. We can say the image and audio. Thank you, sir.
I think you should go for implementation something, okay?
Okay, sir.
All right. So with this, we have come to the end of all the presentations for today. I sincerely thank all the authors for their excellent presentations and contributions in this session, and for all our participants for being a part of this international conference. I hope the session was informative for everyone, and on the behalf of the entire team, I thank you for your support during this 11th version of the conference and all the previous 10 versions. We would be happy to have you in the 12th version in 2027. All the presenters will be receiving their digital certificates through email within the next 2 working days, and the publication should be live in 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Before we finish, I would like to thank our session chair, Dr. Saurabh Chandalia, for chairing the session, and I displayed the certificate on the screen. Sorry, just 1 second. I would like to present this token of appreciation to the chair on behalf of the entire team ICTIS and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Just before we conclude, I would like to request everyone to turn on their cameras for a quick snapshot of the meeting. All right. Thank you so much for joining. You may now leave. The session is adjourned.